Look into Bloom filter today. A Bloom filter is a space efficient probabilistic data structure that has many practical applications. It can be found in network routers, database, web browsers, and more. A Bloom filter is designed to answer the question, is this element in the set? It provides either a firm no or a probably yes, means that a false positive. Two strings having the same value are possible, but false negatives are not. This probabilistic nature is what makes a Bloom filter different from other data structures like hash table. The trade-off of a Bloom filter is that it consumes less memory compared to other data structures like hash table, which provides a perfect answer all the time. So if a use case can tolerate some false positive but not false negative, a Bloom filter can be very useful. One key aspect of Bloom filter is that once an element is added, it cannot be removed. The filter never forgets the element it has added. Now let's explore some real world application of Bloom filter. Many NoSQL database use Bloom filter to reduce the disk space for key that does not exist. This helps minimize the cost operation when searching for non-existent key in LSM tree-based data structures. Content delivery networks like Akamai, CloudFront use Bloom filters to prevent cache one-hit wonder, which are web page requests only once, by tracking URLs seen using a Bloom filter and caching the page only on the second request. The caching workload is significantly reduced, improves cache hit rate. A web browser like Chrome, uses to employ Bloom filter to identify malicious URLs. The filter would perform more expensive full check of the URL only if the Bloom filter returns a probabilistic yes answer. All the number of malicious URLs grew. More efficient but complicated solutions are needed. Similarly, some password validation use Bloom filters to prevent users from using weak password, while strong password may occasionally be a victim of the false positive. So users can be prompted to come up with another strong password. These are just few examples how Bloom filter are utilized. There are many more applications in various domains. Now let's deep dive into how Bloom filter works. The critical component of Bloom filter is having a good hash function that are fast and produce evenly and randomly distributed output. Collisions are acceptable as long as they are rare. A Bloom filter is essentially a large set of buckets like this, with each bucket containing single bit initialized to 0. All these will be initialized to 0. When an element is added, the hash function generates an indices that corresponds to that bucket, and the bits also at that location are set. Now let's consider Suresh as the element whose hash function value is 0, 1 and 12. You can see that the bit is set to 1 at these locations. Now let's take another element, lemon, whose hash function is 5, 6 and 7. The bit is set to 1 for the corresponding indices. Now if you check if lemon is present in the bit set, it would return true, because how many times you compute a hash value for lemon, it will return the same values. So you would go against and check against this bit set. So it will check, is 5 having 1, is 6 having 1 and 7 having 1. If it is all have become true, then it would return true. Now let's see if there will be a collision. Now let's consider as element as Kumar. So this hash value for Kumar will be same as Suresh. So what happens is, now this hash value would point to this one. Now the hash value will be pointing to this one. The same as Suresh, and it would be pointing here. So when you check for Kumar, the hash value returned for Kumar would be 0, 1 and 12. So but this element is actually not present in this bit set, so it would return a false positive. So this case is called false positive. So how do I avoid collision? If you increase the bit set to correct value, it would not lead to collision. So it is important to take the correct bit size array. That is because the bit size array is the one which is used as the modulus operator for the hash function. Okay, now let's see the demonstration of this. Now let's implement the Bloom filter in Java and see how it actually works and how collision can occur. I'll just demonstrate that. For building this, you need mainly two parameters you need to take as an input: the size of the bit array and how many times you're going to perform a hash function on the given element. So let's declare private int number of bit array and copy it. Number of hash function. So let's then create bit sets. Now let's declare public Bloom filter int number of bit array and number of hash function. So then what you do is this dot number of bit array is equal to number of bit arrays. This dot number of hash function is equal to number of hash function, and then you create bit set is equal to new bit set which takes the number of bit arrays. So once you have done this, now you need to create an add method which will take the element and it would set the bits in the bit set array, so against the indexes based on the calculations of the hash function. Public void, it will return nothing, it will just set it elements. So here it will be a for loop, so which means that number of times we have told that number of times that we want to perform the hash function. Right, plus. So now we'll set the bit against that indices. Get hash. So now we'll create a method called get hash to calculate the hash value for the given element. Now you'll use int hash, you'll declare so element dot hash code. So hash, you will take the hash and you'll multiply it with a prime number and add this value. Math.abs, just to avoid negative values. So it will be a modulus on number of bit array, number of bits array, and then you would return the hash. So that's it. It's so simple. So now you would create another method called public, which will return as boolean. Contains, you will pass a string. Now what it will do is it would do the same hash function value as above, but now it is like you're going to get it and check if it is present in the bit set array or not. If it is not present, then you would simply return as false, and if it has completed all the hash function and still it is set in each of the bit, then finally you return it as true. So now let's write the main method, get the instance filter is equal to new Bloom filter. So it will take the number of bit array size. Let's take it as 13, and let's take number of times the hash function has to be performed on that element as 3. Now Bloom filter dot add. Let's add Suresh. Now let's take 11, and then let's check if it is present in the array or not. Dot contains. Let's check for 11. So now let's check if Kumar. So basically you would be expecting it to return false, but it would return as true. So that's where the collision actually occurs. Let's check. So now let's check for something like Google. So now let's run this and see what really happens. So it has written true. So this is actually should have written false, but it has written true because a collision has occurred, and it is thinking that Kumar is present, but Kumar is not present. Only Suresh Kumar is present. So now that's because the size of the array is very small, and it is trying to fit the elements within that array. That's the problem. So now if we increase the size to 200, right? So this would return as false only. See, now you see it's returning false. So in Bloom filter, it is very important to note that you need to calculate the bit array size correctly based on a input, the number of inputs that you want to store. Keep in mind that bit array never forgets once you have set that bit. So the right bit array size is very important to avoid collisions. Yeah, that's it for today in Bloom filter. Catch you up in the next video.